Welcome to the introduction to organic chemistry. Today I am going to take class on alkanes. So I am very happy. Many students are watching my classes and they are saying that it is very important and very interesting examples. Thank you, Anil. And today is alkanes are very important chapter. So then introduction to IUPAC nomenclature and conformational isomerism and constitutional isomerism and the majority IUPAC nomenclature in this class I am going to explain. So we know that what is mean by here. You can see that introduction to IUPAC nomenclature is very important. And for example, this is formic acid and urea and barbiturate acid. So this is a very important drug barbiturate acid. So one of the Bayer, Sir Alfred van Bayer has named this compound. So Barbara. So one of the in the name of this person and another morphine. So this is also one of the important drug that is called morphine, a painkiller named after the Greek god of dreams, morphine. So like this, so there are very interesting examples are there, and so many applications are there, organic compounds, and last class also some medicinal drugs also explained, pharmaceutical interesting examples. And so we know that this is the CH3 and CH3 is the ethane and ethene, and so that it is a acetylene or ethine and benzene. So these are the important examples we know that, but we know that propane and butane and pentane. So for example, number of carbons, 3 carbon, 4 carbon and 5 carbons. So generally we can count the carbons, and now the in the suffix you can use as a "ane", so that so a symmetrical systematic name is given by IUPAC. So how to pronounce this IUPAC. So selecting the very important how to International Union of Pure and Applied Chemistry. So what is that selection is there? So how to select the to find the nomenclature itself for identifying of systematic names. So there are certain rules are there according to the UPSC. One is that selecting, one of the important criteria is that selecting the parent chain. So which is nothing but long chain. So for example, very nice example here I am showing here, and you can see that 1 2 3 4 5 6 7 8 9. So whereas we are giving this direction, it comes 8 carbon. So we have to select first one, choose the longest chain, and second one, the more number of substitutions. You can see that 1 2 3. So that, and one, this is the substitution, and this is the substitution, and this is the substitution, another also. So like that, first one is choose longest chain. So another important criteria is, for example, number of carbon atoms, carbon 1, carbon number 2, carbon 3, number of carbons. And so one carbon is their meth, 2 carbons is their eth, 3 carbons is their prop, 4 carbon is their but, 5 carbons is there in a chain pent, 6 carbon is there it ex. And so if it is a alkane, so ane we have to, each name we have to add ane, methane, ethane, propane, butane, pentane, heptane. So if it is a 7 carbon hept, so heptane, 8 carbon it is octane, 9 carbon nonane, decane, undecane, dodecane. So like that. So that is the very important so in a given nomenclature, so that's very important. And then another is that, so first we have to, for example here they given so how to the incorrect, and we have to go for, so numbering. You can see that 1 2 3 4 5 6 7. So here the longer chain is that number, and this methyl and ethyl, two ethyls are substituent and one methyl. So here another one is the longest chain, and second one is the substituents. You can see, you can select the longer chain here, and it gives the 3 substituents. So that is very important. And you can see here, so same compound, and you can count like this. Here you can see 1 2 3 4 5 6 7. So that here this is the one substituent and here one, so two substituents are coming, so that two substituents is the lesser number, so it is incorrect, whereas three substituent is correct. So like that. And another one, cycloalkanes are important. Cyclo means ring, so it is a three member ring: cyclopropane, cyclobutane and cyclopentane. So that is very important. And another, so from this observation we can learn one skill. So how to, one is the, for example, we can greater the number of substituents. So first point is that number of longer chain. The first one we have to select the, choose the longer chain, and second one is the number of substituents. So very important, you can see that this is the decane chain and it is containing, this is the 1 2 3 4, four substituents are present, so that this is the second one. So for example here, so many examples are there. Identify and name the following compounds. Can students can, for example, you can see this is the 1 2 3 4 5. So 2 ethyl pentane, 2 ethyl pentane. And you can see here, for example, 1 2 3 4 5 6, 1 2 3 4 5 6. So we can give anyone, so that this is the substituent 1 2 3. So 3 propyl hexane, 3 propyl hexane. And another one you can see 1 2 3 4 5 6. So 1 2 3 4. So then you can see this is 3 comma 4 dimethyl 1 2 3 4 5 6 7 heptane. So 3 comma 4 dimethyl heptane. So and 1 methyl cyclopentane, and this is the 1 comma 1 dimethyl cycloheptane, 1 methyl cyclopropane. So like that we have to, you can practice the these are the example you can practice. Students, please note down and practice the IUPAC nomenclature. And you can, so from this example you can select the number of substituents, more number of substituents. And second point is longer chain. So another important is that how to name the substituent. That is very important. For example, you can see here 1 2 3 4 5 6 7 8 9. So now this is considered as a parent chain and it is containing 1 2 3 substituents. So these are the substituents and this is the parent chain. So if it is a parent, you can see that methyl is there and ethyl is there and propyl is there. So for example, name of the alkyl group, for example, 1 carbon is there methyl, 2 carbons are there ethyl, 3 carbons is there propyl, 4 carbons is there butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl, like that. So we have to consider as a substituent. For example, you can see very nice example here. This is the parent chain. So now this is the parent chain and it is now the substituents, 3 substituents are there, and methyl substituent and propyl substituent and ethyl substituent. So according to alphabet, ethyl comes the E, then M, then P. So like that you have to give the IUPAC nomenclature. And you can see this best example, this is the cyclohexane because 6 number is there, and this is the propyl. So now the propyl considered as a substituent and now cyclohexane ring as the parent chain. And similarly you can see, so for example cyclopropane ring is there, and but this is the 1 2 3 4. So now the number of carbon is 4 carbon, but cyclic ring it contains the only 3 carbon. So 4 carbons we need to consider highest. So that's why this is the now propane ring, cyclopropane ring is the substituent. So that what is the IUPAC name? So 1 cyclopropyl butane, 1 cyclopropyl butane. And so name the complex substituents. For example, very tough substituents will be there. How to because we have to, for example, first we need to select a longer chain number. You can see here. So whether 1 2 3 4 5 6 7 8 9, total 13 carbons are there. And so these are the substituents. You can see now here at 6th position and one substituent, and 1 2 3 4. So at 4th position one substituent. So we have to give like this. For example, another example you can see here, and this is the main chain. Please remember student, this is the main chain and this is the substituent. Now again in the substituents, again we have to select longer chain and that substituent. For example, this is called 2 methyl butyl, 2 methyl butyl, that position you can see. For example, you can see 2 methyl butyl and 1 2 3 4 5, fifth position is there. So fifth 2 methyl butyl, and so on. The next one is the longer chain, for example decane or heptane or nonane, like that. And these are the very important skill to learn the students, very important. This is the parent chain, and it may be, if it is a 3 carbons, is the propyl, one propyl, like that. Or you can see that, for example, this is the parent, 4 carbons are there, it is a butyl. Or if it is a parent, 5 carbons is there, pentyl. So it is a straight chain substituent. Otherwise, for example, the parent with, you can see here 1 2 3. So that is means we have to now consider as this one as a, like it is a common name, isopropyl or IUPAC name, 1 methyl ethyl. So now the parent it will be there, and additionally 1 methyl ethyl, like that we have to use. So 1 methyl ethyl, and now this is the parent chain, and now we can call it as isobutyl, because 1 2 3 4 4 carbons is there, we can call it as a isobutyl or IUPAC name 1 2 3. So 2 methyl propyl, 2 methyl propyl, so and parent name. So like that. For example, tertiary butyl is there, it is a parent chain. So now so we have to give at, yeah, so 1 2. So at first position 2 methyls are there, so 1 comma 1 dimethyl ethyl. So tertiary butyl is a common name, and 1 comma 1 dimethyl, 1 comma 1 dimethyl and ethyl. So parent chain we have to call it as. And yeah, so like that. And you can see this is the pentyl, and you can see, for example, yeah, 1 2 3 4 5 6 or 1 2 3 4. So isopentyl or isoamyl or 3 methyl, for example 1 2 3. So 3 methyl butyl, so parent. And another example you can see, for example, this is the 1 2 second position, 2 methyl groups are so. So 2 comma 2 dimethyl propyl, and again parent chain. So like this, very important systematic IUPAC nomenclature. And continuation of this, continuation. So and another example you can see, this is the, for example, these two substituents are there. This substitution is that, so yeah, so 1 methyl, yeah, 1 methyl ethyl, yes, correct. So now we can give one, so like that we have to. So and this one 1 methyl propyl, 1 methyl propyl, like that. And you can see this is the, so you can practice. So this one we have to, for example, you have to count, for example 1 and 2 3. So 2 methyl propyl, like that. So 2 methyl propyl and 1 2 3 4, 1 2 3 4. So fourth position, 4 5 6 7. So so we can call it as a 2 methyl propyl 4 heptane, like that you can. So this one how to give substituent, for example 1 and 2. Okay, so 1 2 3 4 5 6 7 8. शांत गेम. पूरे साल जिनको देखने भक्त हैं. So very important. చిన్నగా 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 నువ్వు త్వరగా నొక్కుతావు, అంత ఫాస్ట్ ఏం పనిలేదు, చిన్నగా. ఇటీ అంతే అంతే. ఇది కిందికి వేసినారు అప్పుడు దీన్ని, అందుకే అట్లా పడతా ఉంది. So then like this you can give the nomenclature. And this one also, this is the parent chain, and 1 2 3 4 5 6 7 8 9. Sound తగ్గేమే. So now this is the parent chain, and now this is the substituent. You can see now 1 2 3. So 2 comma 2 dimethyl propyl, like that. So at fifth position, so 5 dash, so within bracket we have to give 2 comma 2 dimethyl, 2 comma 2 dimethyl propyl and nonane, like that. So very important example. So another one, so assembling the systematic names of alkanes. For example, you can see like this, we have to give 2 methyl pentane and 3 methyl pentane. So where, for example, for case 1, so if one substituent is present, it should be assigned the lower possible number. So how to assign? Lower substitution must be at lower number. For example, you can see this is the correct 1 2 3 4 5. So this is a substituent present at second position, so this is the correct. Whereas we can give in reverse, it is coming 6. So this is the correct representation and this is incorrect representation. And case 2, in case 2, when a multiple substituents are present, so assign the number so that the first substitution receive the lower number. For example, you can see 2 comma 5 comma 5, and rather than, you can see here first must be a second. So now this is the correct representation, but here you can see starting with 3, so this is wrong representation. But you can see two substitutions are there. First are you can see 2 is the lower number and now third is the higher number. So this is the incorrect and this is the correct. So like that. So second is the multiple substituents are present. So first one is the must be the starting with lower number. Case 3. So if there is a, if it is a second and also here also second, then next substituent must be lower number. For example, 2 comma 3 comma 6, at second and third and sixth position substituents are there, but because second and second both are matching, but next one is here, you can see substituents is there at fifth position, but here third position. So this is the, so if there is a tie, then second substituent should be at low as possible. So this is very important. And another one, so you can see here 2 comma 3 comma 6, 2 comma, you can see 2 comma 3 comma 6. So at 2 third and sixth position, so methyls are there. So 2 comma 3, but you can give like this, so 2 and 5 comma 6. So now this is the incorrect number. For example, so 1 2 3, you just give the numbering 1 2 3 4 5 like this, but 2 comma 3 comma 6 is coming, and you can see like this means 2 comma 5 comma 6. Now 2 2 is a matching, but you can see lowest. So now this is the a correct nomenclature and this is the incorrect nomenclature. And another one, so another important is that for example, lowest number should be assigned alphabet. So then lowest number with 4 ethyl and 5 methyl. First one is the lowest number, then alphabet also very important. So 4 ethyl, so 4 ethyl 5 methyl, like that, and 5 ethyl, and so now 5 ethyl and 4 methyl is the incorrect number. Okay, this is the incorrect and this is the, why? Because the lowest number is the next one, alphabet. So these are the very important criteria. So what are that one? For example, you can see this cycloalkanes. So at 1 2, because substituents at 3 is the because 2 substituents are there at first position. So 1 comma 1, 1 comma 1 and 3 trimethyl cyclohexane. So 1 comma 1 comma 3. So now you can see here, so 1 comma 3 comma 3, because highest number. So now this is the incorrect representation, this is the correct. So what is the important? First one is the identify the parent chain, and second one identify and name the substituents, and third one number the parent chain and assign the local end to each substituent. So arrange the substituents alphabetical order. Then finally provide a systematic name for the following compounds. So for example, you can see here some examples are there. For example, you can see substituents are there, 1 2 3 4 5 6, longest chain, then methyl 1 and methyl and ethyl. So these three are substituents. So how we can give the numbering? First one is the 1 comma 2 comma 3 dimethyl and 4 ethyl and nonane. So you can see here 4 ethyl, because alphabet order we have to give the numbering first. So 4 ethyl 2 comma 3 dimethyl octane, because alphabetically it is coming even though the number is 4 ethyl 2 comma 3 dimethyl octane. So like this. So provide a systematic name for the following. So you can see here, you can see 1 2 3, here also 1 2 3 4 5 1 2 3 4 5 6. So this is the correct 1 2 3 4 5 6 7 8 9 10. So now this is a totally 3 substituents are there. So 3 comma 5 comma 8 trimethyl decane. And another one you can see, now this is the cyclohexane is the, because 6 carbons are there, and now this is the substituent less carbon number. So now 1 and 2 3. So how to give the name? 1 methyl propyl cyclohexane. So we can say it is a 1 methyl propyl cyclohexane. So this is the very important. And so we can see that some of the examples here, and you can see following example. This is the you can say that 1 2 3 4 5 and 1 2. Okay, so 1 methyl ethyl like that. So 1 methyl, so 1 comma 3. Okay, so 1 methyl di, like that. We have to give nomenclature, we have to practice it. So now this is the same position. So 1 methyl propyl cyclohexane, and now longest chain we have to select 1 2 3 4 5 6 like that, and these two are substituents. So please practice, these are the examples. And another important criteria is the name the bicyclic compounds. So now bicyclic, now it is a, you can this is the 5-membered ring, and so is the same as like this. So now this is the, this one and this one is called as a bridge. So this one and this one and this one is called bridge. So that you can see like this also, it is a bicyclic. This one represent as a bicyclic. So this is called narborane. So how to give the nomenclature of this one? So bicyclo, because you can see here 2 and 2. So 2 comma 2 and 1, you can see 1 is there. So bicyclo 2 comma 2 comma 1 heptane, and like this. So bicyclo 3 comma 1 comma 1 heptane, bicyclo 2 comma 2 heptane. So start one first. How we can give the numbering? Very important is that start at one of the bridge head along to the, means along the length path. So then substitute the lowest possible number. So for example, very important. So for example, we have to start the at numbering from bridge carbon, but substituent must get the lowest number. For example, we are giving like this 1 2 3 4 5 6 7. So substituent is coming 6, 7th position, but you can give like this. You can start this bridge 1 2 3 4 5 6 7 8 continuous. So it is coming 8th. So now 7th position is the right answer. So that is the correct path, and the correct path place the substituent. So C at C7 rather than C8 is the correct. So what is the name? You can 7 methyl bicyclo. So 4 yeah, highest number, because 4 carbons is there and 2 carbons and 1 carbon and no name. So like that. So what we learn from the what is the learning skill here? For example, assign a name for the following compound. For example, you can see this is the bicyclo compound, and you can give the numbering at bridge. So 1 2 3 4, this is because it is a longer, whereas this one 1 2 3 4. So we have to select the longest chain. So 1 2 3 4 5 6 7. At 7th position 2 methyls are there. At first position again isopropyl is there. So at second 2 isopropyl, 7 comma 7 dimethyl bicyclo, because 1 2 3 outside 3 carbons are there and 2 carbons, and because no bridge no, right? You can see this is the bridge carbon is there, so no such like that. And 3 comma 2 comma heptane. So this is the, and you can practice the following examples, name the following compounds. And another interesting is that vitamin D also. So now it is a bicyclic compound and one hydroxy functional group is there, and you can give the systematic nomenclature. And another, what is the use of this one is that pharmaceutical. So for example, some pharmaceutical important drugs are there, and you can see, so name of common pharmaceutical. For example, So 2 acetoxy, because this is the first position carboxylic acid and second position 2 acetoxy benzoic acid, so it's a very important. And so another this is also very important drug, aspirin, like that. Then this one is called for example ibuprofen. So ibuprofen is one of the important drugs. So what is the IUPAC name of this one? So for example, so 2-4-2 methyl propyl, so this one, for example, 1 2 3, so 2 methyl propyl, like that. 2 methyl at fourth position, so fourth position 2 methyl propyl is there. Then again you can see the this one is 1 1 2, so second position methyl is there. And this one yeah, so methyl and phenyl, you can say it is a phenyl. And yeah, propionic acid, 1 2 3, so propionic acid, like that also you can, is a very important drug. And another one, this is the N. So N substituent is that, so acetyl, so 4 hydroxyphenyl, this is the one, 4 N 4 hydroxyphenyl and ethanamide, because two carbons are there, like that also 4 N 4 hydroxyphenyl ethanamide. So this is called pharmacy, you can call it as acetaminophen. So these are very important, and please practice. So number of constitutional isomers, very important. Molecular formula C3H8 means 1. So these are the please practice IUPAC name. Thank you. And some of the examples also you can practice. So please write the IUPAC name and practice the given examples. Thank you.